In the space of science and gigantic, privileged insights, the subject of what existed ahead of time to the gigantic impact has ignited blended conversations and intrigued characters for quite a while. This epic request doesn't just test how we could disentangle the universe. It challenges the authentic farthest restrictions of human information. Imagine standing at the edge of presence, examining the colossal shadowing, and taking into account what lay there before our universe was imagined. The occasion of the Big Bang denoted the beginning of history, space, and all that we know. At any rate, was there a moment sooner, in advance? Could this have existed? Could there eventually have been a condition of nothingness, a calm before the pompous gathering started? And on the off chance that this is valid, was it? Or perhaps there was something considerably more upsetting that existed before time itself. As we dive further into this request, science takes us on a trip past the universe's beginning stage, into considerations that challenge our mindfulness. Physicist Brian Cox, known for his commitment to the miracles of the universe, suggests that something astonishing might have existed before the Big Bang. He asks us to reconsider our thinking of this present reality and presence. In this evaluation, we'll dismantle the science, the speculation, and the astounding insider secrets that may assist us with understanding what existed prior to all that. We'll investigate contemplations like faithful improvement, quantum changes, dark energy, and even multiverses. The reactions we've uncovered may shock you, but they could also open new understandings of our circumstance in the universe. Prepare to jump deep into a world beyond imagination and science, where the dark still breezes around the shadows, leaving analysts staggered and, at times, indeed, even steamed. We ought to research what existed before the Big Bang and why these hypotheses challenge all that we expected we knew. To appreciate what may have existed beforehand the Big Bang, we first need to examine what the Big Bang truly was. The Big Bang, as analysts describe it, refers to the event when the universe became staggeringly hot and dense, rapidly expanding to set off the development of all matter, energy, and boundless forces. When we look toward the night sky, we see confirmation of this hot beginning, with systems spreading out all over from a beginning point. At any rate, for what reason did this happen? Was there a period before this thick, hot starting? As shown by the speculation of immense expansion, there was without a doubt a before, and it was far from void or tranquil. That's what colossal improvement proposes. Before the Big Bang, the universe was in an express that was cold, unfilled, and free, basically like a gigantic vacuum. At any rate, this vacuum wasn't altogether unfilled. It contained a titanic amount of energy that fueled the quick extension of space itself. This development, called inflation, happened so rapidly that it generally settled the reason for all that would continue in a piece of an ensuing space. It widened at mind-boggling rates until the expansion toned down, and the energy changed into issue particles and the forces we consider the Big Bang. But what was the nature of this energy? Why did it, because of nowhere, foster the universe? And for what reason did it stop? Specialists believe that this boundless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric widening ceaselessly with minuscule air pockets forming to a great extent, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, proposes that there are possibly unlimited Big Bangs and a boundless number of universes. Our own is only one of many. This colossal, mind-boggling reality challenges how we could decipher the very universe itself and leaves us with the inquiry. What else is out there? The prospect of nothingness before the Big Bang is theoretical, not genuine. However, for our ongoing understanding, regardless of whether you kill all energy particles and radiation from the universe, it would still not be genuinely void. Our universe is topped off with dark matter, dark energy, quantum fields, and various forces that weave an inevitable woven craftsmanship of something, even in its most vacant structure. Regardless of whether we imagine stripping away these forces, leaving a dead space, the universe would still make new kinds of energy. This reality alone is confounding to specialists, as it suggests that certified nothingness might be unfathomable within our unlimited appreciation. Space itself has properties, rules, and constants that hold it back from being completely unfilled. Imagine making a region with literally nothing in it. No particles, no radiation, and no energy besides quantum fields and critical constants. These would still exist, suggesting that this nothingness has properties. For instance, there's a plug called zero-point energy, which addresses the most unfathomable energy condition of quantum fields. In this state, particles can still right away appear and scatter, making a frightening resonance of improvement, even in what should be empty space. This challenges what we would call a certified void and suggests that, yes, even before the Big Bang, there was something specialists are still beginning to see. Conceivably, one of the most amazing speculations in current cosmology is the chance of undying advancement. If inflation could create our universe, it's possible it could continue forever. Brian Cox describes an unbelievably monstrous inflationary multiverse, where universes are vastly made and expand. Imagine each Big Bang as a streak lighting one more universe, while inflation happens in various areas, creating countless other universes. This cycle could, in principle, occur perpetually. This idea of gigantic universes siring others leads to a charming thought of a fractal universe, where each new universe may, in fact, make its own Big Bang. Every universe exists as an alternate, independent space, unaffected by the others, considering the fast advancement of room. For researchers, this theory is both energizing and upsetting, as it proposes a perpetual multiverse with no definitive beginning or end. Imagine our universe being simply a tiny bit in a vast, incalculable plan, constantly developing and making new universes. And imagine a situation where the disturbing truth is that there is no before or later, but instead an unfading pattern of universes shaping and decaying. How we could decipher nothingness changes when we consider quantum field theory. As shown by this theory, the universe isn't just a mix of issues floating in space. Perhaps it's a complicated association of energy fields that fill the universe, interacting to make all that we notice. These fields are like indistinct seas, with particles acting as waves or disturbances. Even when fields are at their most minimal energy level, known as the vacuum state, they are still dynamic. Particles can appear and evaporate in these fields quickly, acquiring energy before returning it. This idiosyncrasy creates virtual particles, substances that right away exist and then vanish, leaving just a feeble memory of their presence. The thought of virtual particles challenges the possibility of a real void. Imagine an unfilled universe where all matter, radiation, and energy are removed. Would you have, in fact, nothing? Quantum field theory you wouldn't even. In a vacuum, fields would remain dynamic, sometimes creating transient particles. This consistent development in what should be nothing suggests that the universe doesn't perceive our idea of vacancy. The fields and forces persevere, filling the universe with a secret energy that prevents absolute nothingness. This grasping raises a captivating question: if fields create particles and particles create matter, could the universe itself have risen from this nothingness filled with quantum fields? Dark energy is a strange force that presently drives the accelerated development of our universe. However, did dark energy exist before the Big Bang? From certain points of view, the way that dark energy exists today is an extra of an energy field from before our universe's development. The properties of dark energy seem to suggest a giant, hidden force that could have existed in some form before the Big Bang. Some hypotheses suggest that dark energy in a much stronger state might have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that whether or not our universe were depleted of all matter and radiation, this force would continue to grow the texture of space-time. This thought prompts a disturbing inquiry: if dark energy was present before the Big Bang, might it at some point have formed the conditions that led to the birth of our universe? Might dark energy be the quiet architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not merely as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another hypothesis is that cyclic cosmology offers an alternative to the Big B as the ultimate start. It suggests that the universe goes through vast patterns of birth, death, and revival. In this model, the Big Bang is not a one-time event, but maybe part of an immortal cycle where universes grow, break down, and then recover in another cycle. This hypothesis proposes that our universe could have been renewed from the remnants of a past universe. The course of contraction and development in a cyclic pattern would mean that there was never a real beginning, but rather an eternal series of UN arising, developing, and renewing themselves again and again. Cyclic cosmology raises significant inquiries about time, as it suggests that time itself may be repeating rather than direct. If this hypothesis is right, it could imply that what existed before the Big Bang was simply another form of the universe, one that fell solely to give birth to our current universe. For scientists, this hypothesis offers a rich reply to the question of extreme beginnings, suggesting that there is no obvious start. The universe has always existed in some form, rising above our thoughts of time and presence. Gravitational waves are another interesting concept that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are ripples in spacetime caused by the acceleration of massive objects such as colliding black holes. Some scientists believe that these waves could have originated in the very early stages of the universe during the Big Bang itself, or even before. If this is accurate, it could indicate that there was something that happened before the Big Bang, a disturbance or event that set the stage for the creation of our universe. The prospect of gravitational waves from before the Big Bang presents the possibility of detecting remnants from a time before time itself. Through our journey into the unknown, we find ourselves at the very edge of what is comprehensible. The universe, with all of its complex web of possibilities, continues to stretch beyond our understanding. Is there something before the Big Bang? And if so, what could it have been? As we continue to push the limits of science, we approach a place where mysteries continue to reign supreme. What lies beyond our knowledge may forever remain beyond reach, or maybe one day we'll uncover that before the Big Bang, the universe was just one stage in an eternal cycle, an unending march of creation and destruction, where time and space, like dark energy, continue on forever. As we dive deeper into these cosmic inquiries, we find that the boundaries between known science and speculative theory often blur. One of the most intriguing aspects of the universe's origins is the role of quantum fluctuations in the quantum realm. Tiny fluctuations in energy can lead to the creation of particles that seemingly appear out of nowhere. These fluctuations suggest that the universe's fabric might have sprung from a quantum vacuum where particles are continuously being created and annihilated. The idea of a quantum vacuum doesn't imply a complete absence of existence, but rather a state full of potential where energy is constantly shifting and fluctuating. This aligns with the concept of the universe being born from a quantum fluctuation, possibly driven by quantum fields which might have existed before the Big Bang as the initial spark for the creation of spacetime itself. In this scenario, the Big Bang could be seen not as a singular, explosive event, but as the beginning of a new phase in an ever-evolving quantum field. Some theories even suggest that the observable universe as we know it could be just one in a series of bubbles or regions within a vast cosmic multiverse. Each bubble could have different physical constants and laws of nature. In this view, the Big Bang might not have been unique to our universe, but part of an ongoing process of bubble creation within a larger multiversal structure. These bubbles might have formed as quantum fluctuations in the primordial vacuum, with each universe having a different outcome based on slight variations in its initial conditions. Exploring this further, we encounter the idea that the multiverse may not be entirely inaccessible to us. Some cosmologists believe that the possibility of detecting signatures from Other universes exist, albeit indirectly. For instance, they propose that there might be faint traces of collisions or interactions between our universe and neighboring ones. These traces could be imprinted on the cosmic background, radiation, or even in gravitational waves. As discussed earlier, detecting such evidence would require advancements in our observational tools and technologies. But the prospect of discovering signals from other universes challenges our perception of the universe's limits. Furthermore, the idea of parallel universes opens up exciting avenues for understanding the nature of reality itself. If multiple universes can exist, each with its own set of physical laws, then the very definition of reality could expand far beyond our current understanding. It may also offer solutions to long-standing mysteries, such as the fine-tuning problem. This problem questions why the constants of nature are perfectly suited for the existence of life. If a multiverse exists, with countless universes having different properties, it might simply be a matter of chance that our universe is one that supports life. As we grapple with these mind-bending possibilities, the role of dark matter remains another enigma in understanding the true nature of the universe. Dark matter, which makes up a significant portion of the universe's mass, is invisible to our instruments but exerts a gravitational influence on visible matter. Its origin and properties are still largely unknown, but it could be intimately connected to the fundamental forces that shaped the early universe. Some scientists speculate that dark matter might hold the key to understanding the first moments after the Big Bang, as well as providing insights into the very fabric of space-time itself. In the end, as we push the frontier years of cosmological science, we are not only exploring the universe's past, but also its future. The quest for understanding the origins of the universe, whether it stems from a quantum fluctuation, a cyclic pattern, or from the mysteries of dark energy, may ultimately provide us with a deeper understanding of the nature of existence itself. This journey into the unknown is a testament to human curiosity and the endless desire to uncover the hidden truths of the cosmos.